Good afternoon, ladies and gentlemen. We left off yesterday at problem 45, and we're going to go ahead to 46, moving a heavy object. And so you have a heavy object, a box is being pushed up an inclined plane with that force, and we are asked to find the component form of the force. And how would we do that?
Is gravity in this? Because I kind of remember physics.
Yeah, now really, in real life, gravity would be actually you'd have gravity,
Yeah.
and you would also have friction force,
Yeah.
right? So you'd have gravity and friction.
So none of those two apply to this?
Well, they don't, because what they're doing is they're narrowing the discussion to this vector right here. So that's why they don't apply, because they didn't mention it and bring it into the scenario. But if we wanted to complicate this problem, we could make something up and make it more complicated, more like real life, if we wanted to do that. But we're not going to do that right now.
I already did that last year.
Yeah, that's going to be a future thing. We're just sort of beginning vectors at this point. And so I'm going to call on somebody to tell me component form. I have Riley not here. Get Riley out here. Okay. What I have here is Justin. So Justin, do you have ideas about how to make a component force, component vector out of this? A component form? Remember anything about that?
Is it the one with I and J?
Actually, the I and J is a linear combination. Well, if you want to do that, we could do that as an extension. But component form is what does component form look like?
Like a number and then over the square.
No. Okay. Now remember yesterday. Okay. Here's a vector in component form.
Oh, that, yeah.
All right. So let's go ahead and do that if you could.
So we gotta find out.
Right.
So there's 2.5 cosine 15 degrees.
Okay, so Justin says 2.5 cosine of 15 degrees. Does that look right? Okay. What next, Justin?
Then y is 2.5 sine 15 degrees.
So that's it. So really now what the book wants to do is go ahead and make this a numerical thing, which I think is helpful.
So you get 2.41
So 2.41.
comma 0.647.
647. Okay, does that look about right?
Yeah.
Okay, good, thank you, Justin. And then writing to learn, give an interpretation of horizontal and vertical components of the force. How would you say that?
What does that mean?
What does that mean? He asked. Okay, I will show you. Okay. What that means is this. It means, do you remember when we talked about vectors 101 here a week ago or whenever that was? Remember we talked about that? We talked about this being a vector here. And that the vector, if we pictured it here as on an XY coordinate plane, and this vector happens to have a magnitude of 2.5, and happens to have a direction of 15 degrees. And so what happens is the components are this one right here. So this thing goes right here. And this thing is right here. Does that make sense? So this is the portion of that 2.5 pounds that is pushing it to the right, directly to the right. And this is the portion, 0.6747 pounds, that is pushing up. So you've broken it down into, what do we call this? What form did we call this when I talked about vectors a week ago? Starts with an R.
Right.
Starts with RE. REC. RECT. RECTA.
Is not.
RECTAN. RETCANG.
Rectangular.
Rectangular form, yes. So you've broken this down into rectangular form when you take that and break it down like you do here. Now, do you remember I said rectangular form a week ago when we talked about those? You don't remember that?
Actually,
If you went back and looked at the video, very faintly, yeah. If you went and watched the video, you would hear me talk about rectangular form. But that was a long lecture. That's understandable if you didn't remember a lot of things. They've done studies about how much people forget of things over time. Okay, so now moving a heavy object, I want you to look at this. So it's similar to the last one, kind of, sort of, but instead of pushing up an inclined plane, we are pulling here in this direction. So I want you to look at that and try to make some sense out of it here. Find the force W needed in order for the component of the force parallel to the inclined plane to be 2.5 pounds. Oh my gosh. Give the answer in component form. Just toy with that. To me, it's meant to be an extension of problem 46, but I think it's kind of a significantly advanced extension. Any ideas on this one so far? Jana's shaking her head, I'll tell you. This is one, when I first look at this problem, I'm like Jana, I'm shaking my head, man, how am I gonna do this? But then I go back into say, okay, what it is, they're looking for the force parallel to the inclined plane to be 2.5 pounds. What I'm gonna do is I'm gonna draw one right here like this and make this 2.5 pounds. So I've created that in this direction. So that's 2.5 pounds. And so I need to find the force W that's going to make this thing here pull in a direction of 2.5 pounds. So let's go ahead and find this angle here. So I'm going to move this right up here. So let's go ahead and find this angle, because this angle right here between W and the parallel is going to be important for us. What is that angle going to be? This angle is 33 degrees up here, and this angle here is going to be 15 degrees. So 33 is the whole thing, and 15 is just this part here. So what's theta going to be equal to? Okay, it's going to be 33 minus 15, or 18 degrees. So here's 18 degrees right here between these two, and we need the component of the force parallel. So we want we need this to find what force this is. So we need to have this thing, so we have W, the weight of W, times the cosine of 18 degrees has to be equal to 2.5, as in 2.5 pounds. Does that make sense? Diana thinks it does. Okay, what is it? And I'm standing up here looking at this, and as I do that, I'm kind of puzzling over, am I doing this right? Yeah, that's right. You know that force is going to have to be bigger for its horizontal component to be 2.5 pounds. And so now how do we solve for W? Yeah, we divide by cosine 18 degrees. Cosine 18 degrees. See, I'm writing this in an inclined plane too, in the spirit of it. So 2.5, what is W going to have to be? .63. And then, so that's 2.63. And now it says give your answer in component form. Is this in component form here? Not quite. What I'm going to do is I'm going to put 2.5. And I want more decimal places. Well, let me get my, before I do that, let me get my degrees. There we go. So 2.5 divided by cosine 18 degrees. So we get 2.629, we'll say, or 2.629. So I'm just putting more decimal places because it's like 2.629 pounds. And now it says give the answer in component form. Well, component form is going to be what? It's going to be 2.629 cosine of 33 degrees, right? Comma 2.629 sine of 33 degrees. And then you put that in the calculator, you get whatever it is we get. 2.629 times cosine 33 degrees, 2.205. So 2.205, comma, and then we have 2.629 times sine 33 degrees, 1.432. So this will be our answer. Yeah, this is not. So you have to sort of picture that the inclined plane is like the x-axis initially, to back out what everything is supposed to be here. And while you work on number 48, I'm going to look at the answer in the book just to check. I think it's right. The problem with the book, with this book, is it doesn't give like details on how the problem is worked out. See if that is 2.2, 1.43. Yep, we just have it more decimal places out from the book, but that's what the book has essentially. Okay, I want you to this one right here, I consider to be an important problem for the purposes of this class, in that I think you're going to have a test problem that's going to be quite similar to this one here. Yes.
Have you got your COVID vaccine yet?
No, I have not. I have not got that yet. And I wanted to get it earlier. What happens is I had COVID a couple months ago, and they recommend 90 days after having COVID before getting the vaccine. So I have a few weeks to wait to qualify based on that basis. And so I'm planning on doing it. And I don't know how convinced I am about the effectiveness of the vaccines, but I know my employer would love me to have it. I know my relatives, when I visit over the summer, will be happy for me to have had the vaccine, I'm gonna do it. I think it's the right thing to do.
Well, the shot was easier than any other shot I've ever taken.
Oh, really?
But the after, like what happened, the pain that usually happens after the shot
Yeah,
is way worse than anything ever,
it's way worse, yeah.
like with any other shot.
Which brand of vaccine did you get?
Moderna.
Moderna? Yeah. I think I want to get the Johnson & Johnson vaccine, which is the one shot.
That was canceled.
Well, it was canceled. They were thinking of bringing it back.
Oh, yeah, I was gonna get that one.
Yeah.
And then they canceled my appointment because of the cancel.
Because of the cancer, yeah.
I
So you just
think
got the first vaccine of Moderna. Where did you get it at?
Started at 40 almost.
Okay, for the Walmart. I've been talking to the people down here at Brookshire's.
Yeah, you can get it at a
in
lot of
Kaufman.
places. You just
Yeah.
have to like secure a spot.
Yeah, they'll do it. Okay, Karina, did you figure this one out?
I'm not too sure.
Okay, well, just tell me what you're not sure. We'll just write it down and we'll see. We'll fix it if it's not. How's that?
I don't know.
Okay,
I'm not sure what I was.
now, what happens is,
Oh, I know.
I'm going to show you what Karina wrote down because it's good work. Okay, she wrote this down as a 23 cosine of 18 degrees, comma, 23 sine 18 degrees. Does that look right? Is everybody okay with that so far? Okay. And then right below it, she wrote 27 cosine 15 degrees, comma, 27 sine 15 degrees.
I don't know where I got 17 from, but I put 27, sine 17. I don't know where I had it.
And then when she got this here, she got 47.954 comma 14.096. Okay, does that look right? Okay. I will tell you something. Can anybody notice, what did we notice about this? Do you notice something about this? There's something wrong with the way that she conceptualized this. And every class I've had teaching the subject for the last 10 years, it's been the same problem. What is missing here? It has to do with direction.
That could be negative.
Okay, there are choices you have to make here, okay? So she asked the question, has to be negative. That's one way of doing it. And what we're going to have to do, it has to be negative. Yes. So what it is, this angle is rotating in a different direction. So if we just make that negative here, and we make that negative, we will fix it, okay? Does that make sense?
They're going in.
Pardon me? Yeah, that's fine. Okay, so that is going to fix it. And while she fixes it and gives me what the component form is, I'm going to write an alternative version of this to the left.
Oh yeah, mathematics.
But you passed, right?
Yeah, I passed. By, I think, 2 points.
Okay, so you passed by 1 or 2 questions. See, that's one of those kinds of tests that just passing it is just as good as getting a perfect score on it.
Oh, yeah. They said as long as you pass it, you don't need to take it again.
Yeah. Does it make sense why that angle has to be negative there? Okay, what I did here is I wrote down an alternative version of it. Instead of making the angle negative, what can you do instead? Okay, you can standard positionize it and have it go, that angle's going to be 345 degrees, right? Around that way. So that's one, this is another way of doing it that gives you the same answer. Whatever she's going to tell me here, this will give you the same answer here.
Yeah, I just thought about that.
Yeah. But I'm writing that down there because I want you to be open-minded about the 360 degrees of direction available in a circle. So, what do we have for this one
Well,
here?
when I checked this one, it was the same one that this one.
Yeah, so she noticed that the cosine was the same one, that because the cosine of negative 15 degrees is the same as the cosine of 15 degrees, right? It's just the sign that is off. So that's going to be 47.954. And this one over here is going to be 0.119. Okay, and now it says, how hard is corporal? What do we have to do to find how hard corporal is pulling? We have to go ahead and find the magnitude of this component vector. And what you're going to find out when you do that, so you're going to have 47.954 squared plus 0.119 squared.
Bless you.
And so what is the force going to be when we do that? I predict it's going to be 47.9 something.
$47.954.
954? 4, okay. Okay, do you notice that it's the same thing here? It's the same thing as the x component. So what is happening here? What happens, it's like the y directions canceled each other out. And so all you're left with is the x force, essentially. So that's going to be your answer to that, okay? Questions on that one? Okay, next, let's go to
Teachers and students, pardon the interruption. Just a quick announcement. Right now, Terrell Blanton is in the finals of the long jump, and he's placed third right now. He is 2 inches away from second place. So, everybody kind of maybe give a little positive thought as he attempts to qualify for state. He just needs to get on the board and jump 2 inches further. So, keep positive vibes going, and if I get any information, I will share it as we go. Thank you.
okay. This one here, navigation. We have a ship heading due north at 12 miles per hour. The current is flowing southwest at 4 miles per hour. Find the actual bearing and speed of the ship. You know how that one works out? Yeah, thanks. You know how to do this one? We're gonna do some position problems next week that are related to this, get some more experience next week on this. Did I give you one of those stickers? I did, didn't I?
Yeah.
I did, okay, good.
Oh, Mr. Keith, are those the shirts?
Oh, no, what's happening? I'll tell you, you asked about the shirts. Thank you for asking about it. Should pick them up tomorrow. You guys with your shirts. Okay, this one here, what we have is, we have it's like an XY coordinate plane. So you consider that to be east, north, west, south. And so you're heading north at 12 miles per hour. So here's your north, 12 miles per hour. That's going to be 12 miles per hour. And then it says a current is flowing southwest at 4 miles per hour. So when you say southwest, what direction is that going to be?
In the middle of south.
In the middle, yeah. So this one here is 4 miles per hour. And here, your angle here is going to be 90 degrees. And what's this angle here going to be?
Two 25.
225 degrees, exactly. So what we have here is find the actual bearing and speed of the ship. So what we have is, we have 12 cosine of 90 degrees, comma, 12 sine 90 degrees. Plus, what is this right here? 4 cosine of what angle? 225 degrees, comma, 4 sine 225 degrees. And I happen to know that 12 cosine 90 degrees, that's going to be 0. And this one right here, I happen to know that this is going to be equal to 12. So basically what you have is 4 cosine 225 degrees. And this one's going to be 12 plus 4 sine 225 degrees. So negative 2.828. And then you have 12 plus 4 sine 225 degrees. Now I know it's going to be 12 minus 2.828, so 4 sine 225 degrees. So 9.172. So find the actual bearing and speed of the ship. What's that going to be? Speed is going to be equal to negative 2.828 squared plus 9.172 squared. So negative 8 or 2.828 squared plus, I'm going to put answer squared, second ANS squared, save time. So that's going to be our our speed, 9.598. .598. That's going to be miles per hour, and what direction is going to be? Direction is going to be inverse tangent of, I'll just put y over x, plus 180, right? So inverse tangent of y, and y is going to be this value here, 9.172 over negative 2.828, and we're going to add to that 180, so we get 107.136. So it's going to end up being essentially over here. So we're going to like finish on 52 on Monday, turn that in and start working on some other exercises.